Okay, so before determining which cells are in which stage of the cell cycle, you have to orient yourself with the parts of the root. The part that we're looking at now is what we call the protective root cap. And that part doesn't have much cell division. It's actually a barrier for the root as it goes through the ground. But beyond that, and even in this, you'll notice that the number of purple nuclei begins to increase. And that's because that's where the cells are actively dividing within the root. That's what we call the region of cell division. And then beyond that is what we call the region of elongation. And so your best bet at finding cells at different stages of the cell cycle is to look pretty much from this point into the region of elongation. So what you want to do is you want to just take any particular vertical sort of row, and you want to use the two knobs on the stage. One will move you left and right, and one will move you up and down. So the idea here is to move the stage vertically, and you can choose to either count 30 cells as you move vertically, or you can sort of move in chunks, maybe count 7 or 8 cells and then move the stage, count another 7, 8 cells, and do it that way. Now I'm going to show you what I think is the most difficult way, but I want you to be able to see the pattern. And so as we go through, we're going to start moving this vertically, and you'll notice that, and I'm going to move over just a little bit because there's a cell here I'd like you to see. This would be an example of probably metaphase. When I look at this, I see the chromosomes are not inside the nuclear envelope, so they've already come outside the nuclear envelope, so I'm probably going to go with metaphase on this one. We're going to continue to move. 1, 2, 3, 4, 5, 6, 7, so forth, 8, 9. Most of these are in prophase. This one here is probably in interphase. Notice it's not very dense, it's not too big, as opposed to the next one, which has a granulated appearance, fairly dense and fairly large. It's probably prophase. We continue to move along. This is oriented really well for this. Continue chugging along. And then we get to a point where, wow, look at that. We've got anaphase right here. This is a great example of anaphase. So we're going to continue moving along, move it over maybe a little bit. You know, right here I might just jump over. For the sake of data, I'm going to jump over because it looks like there's not too much going on in that column. Keep going, keep going, keep going. And I've kind of lost track, so I'm just going to move up a little bit more here. And most of those, again, prophase. Now you would be counting how many of the cells you saw in prophase, how many in interphase. Looks like we got one here in metaphase. Now we're going to go down. We're going to go in the opposite direction, the same number of cells. So we keep going, mostly prophase, maybe interphase here. I'm going to skip over a little bit just because I'm, again, you got to do some rough justice. This here, I would say, is probably metaphase. As we continue on, I would say that this is probably metaphase as well. Keep going along, maybe move this over just a little bit. Oops, wrong way. Go now, prophase. Probably interphase. Get down to here. That's a really good example of probably the beginning stages of anaphase. I'm going to continue moving on. There's an interphase right there. Keep moving. And then what we're going to do is we're going to move over again. And we're going to start to, I'm just going to move over a few more here. You don't have to go like adjacent rows. You can just sort of continue over maybe a couple of rows as long as you keep the pattern of up and down. So we're going to go over here. You can see that we've got a nice example of prophase coming up. It's sort of right there. Okay, so we're going to jump back into my original row. There we go. There's a nice example of anaphase. The cells are moving apart. Keep moving along. These are mostly prophase. I'm going to move over here because I'm seeing something that we didn't see yet. I'm going to go over here. This here is a great example of telophase. You can see the cell plate starting to form between the two newly formed nuclei. That's a great example. Cytokinesis would follow. So I'm just going to jump back over to where I was. There we go. Continue moving. Prophase, 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 interphase, 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 probably interphase. You don't even see much of the nucleus here. Interphase, prophase, prophase, interphase, prophase, and so forth. I'm going to kind of move back over here. There's a prophase up there. So, you do the best you can. It's not perfect, but even if you jump around to adjacent rows, you're still probably going to come up with the same data in terms of percentage. Now, once you've tallied up how many of the cells were in prophase, metaphase, anaphase, and telophase, you're then going to go ahead, and since there were 90 cells, you're going to find out the percentages of those cells in those phases. And once you find the percentages of the cells in those phases, you're going to use those percentages to calculate the amount of time. And the entire cell cycle for this particular specimen is about 19 hours or 1140 minutes. So if you had, say, 50% of the cells were in prophase, you would multiply 1140 by 0.50 and so forth. And that's how you collect your data.